Hey, good evening, Red Devil Chemist. It's Coach Scott again with another fantastic video, a video on how to do your homework, more or less, right? So we're looking at Gas Laws Worksheet 6A. We'll look at question 4, 5, or excuse me, 4, 5, and 6 on this one. And let's just get right down into it. So, the question asks, which gas law can relate volume and temperature? Volume and temperature. Now, knowing the absolute name of the gas law, nobody really cares. But you do need to know the relationship. All right? So volume. As volume increases, temperature will increase. As you heat a balloon, right, that balloon, the volume is going to increase. So it is a direct, it's directly proportional. As volume goes up, temperature goes up. As temperature goes up, volume goes up. Straight line relationship. All right? So we can express it mathematically like this. V over T equals a constant. Okay? Another way of expressing it would be V1 over T1, okay, is V2 over T2. So that means as volume goes up, temperature goes up. Once we get to that new volume, the temperature is directly proportional to that new volume. So let's look at this. And again, identifying your variables and identifying the ones that don't change is a big part of being very successful with these gas law problems. Now let's look at question 5. Calculate the new volume of a gas if 1.23 liters of it, initially at a temperature of 32 degrees C, 32 degrees C, we don't use C in gas laws. We don't use Celsius. We use Kelvin. So whenever we see C, we know we immediately have to convert that into Kelvin, which is relatively easy. We add 273 degrees to it. So initially at a temperature of 32 degrees C is subjected to a drop in temperature of 19 degrees Celsius. So that does not mean it's 32 then 19. Read how the question is written. Is subjected to a drop in temperature of 19 degrees Celsius. So it goes from 32 degrees Celsius down 19 degrees, and well, I'd have to think about it, but we can work it out. So did I see anything about pressure? No. That tells me that pressure is constant. So I don't have to worry about pressure. It's the same. It's not changed. So let's write this sucker out. So the initial volume, all right, is 1.23 liters. The initial temperature is 3 degrees C. 32 degrees C rather. So this is what I would suggest. When you write down your 32 degrees C, go ahead, bite the bullet, whatever you want to call it, grab you a pen, a pencil, and go ahead and add 273 degrees and 32 plus 273, so I can do it in my head, 305? 305, put the right unit in, Kelvin. Now you don't have to put degrees Kelvin, it's just understood. For now I just did. All right. So the new volume, I don't know. That's what we're trying to find out. So we'll just put a question mark there, and we'll call it V2 in the equation. Now notice what it says here. Initially it's at 305 degrees K. So this is sort of cool. A degree Kelvin is the same equivalent, the same magnitude of 1 degree Celsius. So if it dropped 19 degrees Celsius, how many degrees K did it drop? 19 degrees K, because it's the same magnitude. So I'm at 305 Kelvin initially, and then it dropped 19 degrees Kelvin, or Celsius. So 305 minus 19. Sorry guys, it's late at night and like my brain is fried. Minus 19. I get 286 degrees Celsius. Excuse me, 286 Kelvin. So that's my second temperature. So let's go ahead and set this sucker up. V1 over T1 equals V2 over T2. I don't know V2, but I do know V1. That's 1.23 liters over 305 degrees K, right? Because I did my conversion right. I went ahead and did it. I don't know. I'm going to use the big orange here. So, oops, sorry, that's not for Tennessee. So V2, go Tigers, over T2, which is 286K. Now I'm trying to solve for V2, right? I'm trying to solve for V2. So what do I have to do? If I multiply this by 286 or by itself, all right, if you have an inverse of 286 and you multiply it by 280, the same number, you get 1. So that's what I'm doing. So let's knock that out. But if I multiply that by on that side, I have to multiply it on this side, okay, because it's the distributive or the commutative property, I think. Don't teach math. All right, so if I do my arithmetic, 286 times 1.23 liters divided by 305K, and I know I'm right because if I cancel out the K's, I'm going to get liters, and it's asking for volume. I get a volume of 1.15 liters of gas. V2 equal 1.15 liters. Now let's see if this makes sense. The initial temperature went down from 305 to 286. It's directly proportional. So that means if temperature goes down, the volume will go down. And we started at 1.23 liters. Volume went down to 1.15 liters. It makes sense. Box that sucker in and ship it FedEx. Go Memphis. Okay. So let's look at number 6 here. Number 6. Calculate the new volume of a gas if 12.78 liters of it, initially at a temperature of minus 50 degrees C, is heated to a temperature of 28 degrees C. Let's go ahead and set this sucker up. So the new volume of a gas, if was originally at 12.78 liters, V1 12.78 liters. All right, the initial temperature, the beginning temperature was minus 50 degrees C. Ooh, I got 4 significant figures there, so I need to report 4 figures. Minus, or degrees C, that's minus 50. So what I need to do, I need to add 273 to it. So if I do minus 50 plus 273, I get 223 degrees Kelvin. All right, so let's go ahead and write V2 over here. V2, I don't know. Trying to find it out. Temperature increased to 28 degrees C. I'm going to go ahead and add 273 to get it into Kelvin. Let's see. So I got 301 Kelvin. All right, 301 Kelvin. Ooh, I'm ready to do the problem. V1 over T1, let me move this down a little bit. All right, equals V2 over T2. Initial volume is 12.78 liters. All right, initial temperature, where it started at was 223 K. I don't know the new volume, so we'll say that's V2. That's what I'm trying to find. 301 K was the final temperature. So let's think. Temperature increased. What should pressure do? Pressure should also increase. Excuse me, I said pressure. Volume should do what? It should also go up. All right. Pressure increases, volume increases. So let's see how we're going to solve this. Oh, I know algebra. So if I have 301k, multiply through on that side, I've got to do it on this side too. Yeah, this is getting a little boring now. K, that's going to, K. I made it funny. All right, so that's V2. So what have I got? I've got 301k times 12.78 liters divided by 223k. I get 1.7, and I got to do 4 sig figs because it gave me 4 digits. It's 1.725 liters. And we'll see if it makes sense here in just a minute. 1.725 liters. So we started with 12 point, ooh. So we got really cold, we got really warm. Let's see if I did that right. No, 17.25 liters. I don't know how to read my calculator. Look, that didn't make sense. And whenever you work these problems, make sure they make sense. So I initially started with 223K. My temperature increased, so volume should increase. It started at 1278. If I would have written down 1.725 liters, I would have lost some points. But if I go from 12.78 liters to 17.25 liters, I've increased the volume. And it should increase. So anyway, there's problems 4 through 6. Pretty much the Charles Laws problems. So, okay, guys, this is Coach Scott saying peace out until tomorrow.